Okay, now if you have read the question, you realize that there are three parts to the question. The first part talks about bisecting an angle. So the implication of bisecting an angle means, right, you are getting after you cut the angle, you get same angle. So in a way, it cut the angle into half. So that is the indication that I may be using algebra, like one of the previous example that we did. And second part, we got to prove similar. So that also meant that we might need some angle. And the last part is some ratio. So that will be the ratio that comes with similar triangle. So all in all, for this question, we are expecting to use some algebra, and then also the ratio that come from similar triangle. So let's talk about part A first. So, and remember I mentioned, right, part A can be helping you part B can be helping you part C. So everything are linked. So for part A, we are trying to prove that BE will bisect a big angle. So the big angle is here. So the idea of bisect, right, means it will be cutting into equal angle. So you might want to, so the idea here is both of them must be the same values. So you want to make the two values, the two angles, same algebra. So the technique will be you choose one of them to start with. So you choose one of them to start with. So in this case, I'm going to choose this to start with. Okay, so I am going to choose this to start with. And then, right, okay, let's talk about it first. So let's choose AEB to be X first. So when I choose this to be X, right, my aim will be, I would like BEC to be X as well. So this is what you start with, this is your aim. Okay, after this, right, once you have this idea already, you play around with your pencil. That means you scribble things around the diagram in order to achieve your aim. So you don't write out the proof first. So you should be exploring first. So if you have explored around the X that you set up, okay, look at the X that you set up. It is from a chord. And the question mentioned that this is a tangent. So that should make you remind of tangent chord theorem. So this is the tangent chord theorem. So the reason why this is an X is due to tangent chord theorem. Okay, then after that, we just explore around first to see whether eventually we can get our aim. Once we can get our aim, then we backtrack the steps to write out the proof. So I also see that there is another 90-degree here. So this 90-degree is angle on a straight line. So if you do 180 to minus the 90-degree, you will get this. So as you discover more angle, okay, so for example here, if you look carefully, right, I can use angle sum of triangle, 180 minus this to get this angle. So 180 minus 90 minus X, that will have given me a 90 minus X. So that is an angle sum of triangle. Then after that, the question did mention something about a diameter. So the diameter will have created a 90-degree. So locate the 90-degree here. So this green 90-degree is due to angle in a semicircle. And subsequently, if you look at your aim, remember this is your aim. Your aim is trying to get that as an X. So now I'm going to explore. If I use the 90-degree from the angle in the semicircle, and I'm going to subtract this angle sum that I've gotten, I will have gotten my X. So after you scribble around, you achieve your aim already. Your job is to backtrack. So you got to backtrack the steps. So the first step is here. The second step is here. The angle on the straight line. The third step is here. The fourth step is the diameter, angle in the diameter. So that is the fourth step. So this will be the 4 steps that you need to lay out. So you play around first, and then play around already to make sure you achieve your aim already. Then you backtrack your steps to lay out. So here, I already let AEB be the starting point. So then my first step is to lay out the tangent chord. So that's it. That's my first step done. My second step is to explain the 90-degree that I gotten on the straight line. So I will explain the 90-degree that is on the straight line. So second step done. The third step is the angle sum of triangle. So if you are executing the angle sum of triangle, it will be good that you explain which triangle is that. Particularly this, if you see a diagram, there's a lot of triangle. So we are executing in triangle CDE. So you are executing in CDE. So you can write about that. So angle sum of triangle. And just now we make use of a 90-degree that follows from the diameter, the green 90-degree there. So do explain that there is an important feature because it's supported by a proper property. You will get marks deducted off if you do not explain the critical 90-degree. So after I lay out all the steps, I will get my aim. So BEC is BED subtracting CED. So I use the 90-degree from the diameter and I subtract the angle that I got from angle sum. So you achieve your aim already. So when you achieve your aim, that doesn't mean that you stop there. Nobody will see the relation if, let's say, you never explain. So you must have a concluding statement. So the concluding statement will be the two angles, the angles that you start with and the angles that you end up with are both x. So the conclusion will be BE bisect AEC. Okay, so that's how you play around with algebra. You get it started first, but then during the process, right, you got to play around with it. Maybe it doesn't work. So when it doesn't work, you got to change the choice of your algebra sometimes. Okay, so that is for question 5A.